This is the first part of your notes that we're talking about. We'll jump straight into it. This is example 1. If you actually go to your books, on page 128, it's the example problem that we're working through. I'm going to try to explain it to you, okay? So, given a point and a vertex, h comma k, we're going to write an equation using the vertex and that point. So example 1 says, the graph shows the parabolic path of a performer who was shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. The performer lands in a net 90 feet away from the cannon. What is the height of the net? So it's asking two things. So the first thing we have to do is go ahead and write an equation for it. So if you look at your notes, here's where we go from. We have this equation right here. I'm going to go ahead and plug in our vertex, h comma k. This right here is my vertex. H comma k is 50 comma 35. Okay? So y equals a, open, x minus h, in this case 50, squared, plus k, 35. Awesome. What we need to do is we need to solve for a. So that's what's in the notes. So we need to solve for a. We've got the vertex plugged in, hk, but we also have a point, and that's where it starts at 0, 15. So this is the x, and this is the y. So I can plug those in for here, boom, x and y, and solve for a. So let's go ahead and plug that in. Y is 15, so I got 15 equals a, open, x, 0, minus 50, squared, plus 35. Okay, so what we're going to end up doing, I'm kind of speed running this. Negative 50 squared is going to be 2,500. So we got a, well, let's do this. 2,500 times a. If I minus 35 on both sides, I'm going to get equals negative 20. So I get this, I divide by 2,500, divide by 2,500, and you're going to get a is equal to negative 0.008. That's when you turn the page in your notes. So now, I've got a, I've got this, I'm going to go ahead and erase this, give myself some room here. So what I'm going to do now is I'm going to plug in a, h, and k. So I get y equals negative 0.008, open, that's my a, x minus 50 squared plus 35. Now, in order to find, the second part of the question was the performer lands in a net 90 feet away from the cannon. What is the height of the net? We know that the height is y, so I'm looking for the y. It's giving me 90 feet away, so that's the x. So I plug this in, and I would use a calculator for this because more than likely I would not want to do this by hand. And once you plug that in, your y equals, you would end up getting y equals 22.2 feet. Heck yeah, brother. Game on. Next example. Okay, example 2. Use x-intercepts and a point to write an equation. We're going off this. Y equals a, open, x minus p, x minus q, where p and q are the x-intercepts. So we have our problem. It goes, a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight, and y is the temperature in Celsius. Okay, A, write a function f that models the temperature over time. What is the coldest temperature? And then B, what is the average rate of change in temperature over the interval in which the temperature is decreasing or increasing? Compare the average rates of change. All right, this is on page 129 in your book. It's example 2. So the first thing we need to do is we need to write a function. Well, our P is 4, x-intercept. Our Q is 24. Okay, so let's go ahead. We end up having to, we're going to have to solve for A, again in this case. So first off, let's plug in what we have. Y equals A, x minus 4, x minus 24. Okay, awesome. Now, I've got this other point, which is right over here, 0.96. Plug that in. Here's my x that'll go in, is going to be 0. And here's my y, 9.6. So I get 9.6 equals A, open, 0 minus 4 times 0 minus 24. Okay, as you end up doing this, it's going to be 0 minus 4 is negative 4. and negative 24. Negative 4 times negative 24 is 96. So we get 9.6 equals 4 times 24 is 96 times A. Divide both sides by 96. A is going to give us 0.1. So I can now represent an equation here that would give me y equals 0.1 open x minus 4 open x minus 24. So that would be my equation that's in x-intercept form. Move on to the next. I brought up my equation up here. And so part A of this example says, write a function f that models the temperature over time. We've done that part. And find the coldest temperature. Well, we need to find y, right? So we need to find what's the coldest, what's the bottom of this temperature. If this is where the temperature is, temp, right? The bottom. Well, that's going to be, since this parabola opens up, that's going to be our minimum value that we need to find. Okay, so what I'm going to need to end up doing is find the minimum value. In order to do that, that's going to be found that y value of where the axis of symmetry is. Okay, so nothing changes. I have to find the axis of symmetry. We do q plus p over 2. So it's going to be 24 plus 4 over 2. So give us 24 is 28 divided by 2 is 14 is the axis of symmetry. Now I have to plug this in here to get that temperature. So we'll do 0.1 times 14 minus 4 and 14 minus 24. It's going to give us 10.1 times 10 times, what's that, negative 10. Okay? Now, if I do my my calculations correct, it's going to be 0.1 times negative 100. And 0.1 move the decimal over. So the temperature, the coldest temperature is going to be negative 10 degrees Celsius because it's in Celsius. So that's part A. Super easy, barely an inconvenience. Let's move on to part B. So now part B, it's asking us to find the rate of change. And the rate of change is basically, we're finding the slope. So what we need to do here is we need to find the difference of this slope from this line to this line. Okay? So I know my axis of symmetry, my AOS, is x equals 14. So it decreases to the left of x equals 14. That's where I get this in the notes. That's what it should look like. Decreases to the left. And to the right, it's going to increase. Beautiful. Now I need to find the slope of the points to the left with the vertex. So that's rise over run. So I'm going to do, write it out over here for you, rise over run. So in here, let's go, boom. My vertex was 14 comma negative 10. That's what this point was. So now I need to do the rise. Negative 10 minus 9.6 over 14 minus 0. Which equals negative 19.6 over 14, which equals negative 1.4. This is the decrease. Decreases, okay? I have to do the same thing with this. I'm finding the slope, right? That rate of change is just the slope. So I found the slope of this line. I need to find the slope of this line too. So in order to do that, I'm going to take my 0 here minus negative 10 over 0 minus negative 10, 24 here, the rise, y's over the run. So 24 minus 14, you guessed it, Shigang. And that is going to give us, well, the opposite of negative 10, which is 10 over 10, which is just 1. So the slope here is 1. Now, to find out which one, because the question is asking what's the average rate of change in temperature over the interval in which the temperature is decreasing, found that out here. And what is it whenever it increases? Found that out here. Now it's asking, compare the average rates of change. Even though this is negative, the magnitude of this, or the absolute value, this is greater. So what that gives us is then, is that 1.4 is greater. So 1.4, I guess here, is the greater rate.